For a quick review of dilations, we are looking for enlargements, are making a shape bigger, but keeping the shape the same, but only changing the size. A reduction would make the shape smaller. As long as the shape does not change, you have a dilation. So, for example, if I did something real crazy to this poor fellow here, right? No longer a dilation. It has to remain with the same shape that you started with. Now, when we were doing dilations, you always want to dilate about the origin if possible. So if it doesn't specify where the dilation is coming from, then you're dilating about the origin. So for this problem, the scale factor is 4, excuse me, which means the scale factor is 1 unit equals 4 units, which means that we are enlarging or getting bigger. So if we look at each individual point, let's start with A, comes first in the alphabet, which is back 2 and up 2 from the origin. It now needs to be back 8 and up 8 because we are enlarging. So back 8 and up 8 puts us right here for A prime. B, by extension, is over 1 and up 2, so B prime must be over 4 and up 8. And because you know that A and B are parallel to each other, that means that A prime and B prime must also be parallel to each other. C is over 2 and down 1, so it needs to be over 8, 2, 4, 6, 8, and down 4, which would put C prime as right here. And then D prime needs to be parallel to both C and A, which means that D prime will be right here. Frequently, when you're done drawing these figures, the best way to tell if they change shape is simply the eye test. Simply look at, does this shape look like it is the same as the shape we started with? Which for me, these do look the same. Therefore, we are dilating correctly. So now we got a crazy looking polygon, LMNOP, and we'll make the letters here LMNOP right here. So we want to dilate with a scale factor of 1/4, which means we are reducing by an order of 4. So we take every individual measurement and we're going to divide by 4. Now L, if we notice, is at 0, 0. And if we're dilating about the origin, that means that we should stay at 0, 0. So L prime and L are in the same place. If we go to M next, which is over 4 and up 4, we need to reduce that by an order of 1/4. So it'd be over 1 and up 1. Our new M is right here. N is over 4, 5, 6, 7, 8, 9, 10, and up 4. Well, 10 divided by 4 is a decimal. It's actually 5/2, or if you wrote it as a decimal, it would be 2.5, which means that we're going to go over 2.5, but stay up 1. Now, O is going to be directly down from N, so that means we have to do 1 divided by 4. Uh-oh, we have a decimal again. Who made these problems? So we get 25 hundredths, which 1/4 is going to be just down here. It's going to be 1/2 of a half. And that'll make P have to be right here. And you're probably going to be asking right away, wait, we're getting a bunch of decimals here. Where are we going to get decimals in our problems? And the answer is you will not get decimals on IXL specifically, but you very much could get decimals on the worksheet problems. And if you notice on this problem, the hardest part was actually the dividing, getting the decimal. Once you have the decimal, the graph should once again stay similar to the shape that you started with. So the graphing itself is the same difficulty, but when you get decimals, you have to be very careful to make sure you don't make a mistake. What scale factor was used to dilate the black polygon, that's this one here, A, B, C, D, into the blue one, that's A prime, B prime, C prime, D prime? So like last time, what I like to do is I like to find an edge that matches. So a corresponding side of BC is going to be B prime C prime. So if I find the measurements for each, it will probably tell me what scale factor is used. And since we are doing a reduction, we should make sure that we are getting a number that is smaller than 1 when we're done. So BC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. And B prime C prime is 1, 2, 3, 4 units long. So we need some number times 12 that gives us 4. And I'm hoping that my 7th graders and 8th graders know that 12 times a third is equal to 4. Therefore, its 1 unit is equal to a third of a unit as our scale factor. So now let's do some angle measurements here like last time. If the measure of angle B, that's right up here, is 85 degrees, what is the measure of angle C prime? So that's right down here. So I know that if B is 85, B prime has to also be 85. And like last time, these angles must be linear pair, equal to 180. So if I do 180 degrees minus 85 degrees, I should get 95. So that means that the measure of angle C prime is equal to 95 degrees. And coincidentally, that means that the measure of angle C has to be equal to 95 degrees as well. So dilations, the math is a little bit lower than some of the other processes in transformations, but it is very easy to make a small mistake here. So make sure you double check all of your answers. Make sure you're very careful when you get those decimals or those fractions because they can be really tricky as well. As always, if you have any questions, please let me know.